Okay, today is Unit 1, Day 6a, and we're going to do some graphical transformations. Now, we're going to do, specifically today, or to start out with, we're going to do some things that are called translations. So a translation is an operation that shifts the graph horizontally, vertically, or both. It can result in a graph of the same, or it results in a graph in the same size and shape, but it has a different position. So you can use Desmos if you'd like, but let's graph these and let's compare those. Okay, so here I pulled up Desmos. We're going to compare A and B, it says. We'll look at A compared to B, and I got them on the graph over here. So A is the red, and I'll just do this. I can turn that off. So there's A, and there's B, and look at them together. What happened? Well, on this one, it's kind of easy to see that it shifted down 3 units. Okay. Now let's go back and change this to a +2. And again, we'll turn this off. Here's the original. Here's A, and there's C with it. If you look, it went up 2 units. So that one was a shift up 2 units. Now we need to change this to D. So I'm going to change this to -3. And again, I'll shut this off. Here's A. There's D. So what's the difference? Well, it went 3 units to the right on this. So even though that was a minus, it goes to the right. You think minus would be left, but it's actually to the right. So this is a shift to the right 3 units. I'm going to go back and change this to a +2. Again, turn this off. Here's the original. Here's E. It's 2 units to the left. So shift left 2 units. So a quick refresher from last year is, and this is with any function, not just absolute value, but if something is being added or subtracted to the end, that's going to be up or down, and it is what you think. You know, negative or a minus would be down, a positive would be up. If it's inside with the function, you're going to be, and what's going on here is you're subtracting from x and then applying the operation. So what you're doing is you're taking x, like say if I plug in 0, or let's say 3, let's say I plug in 3 is my x value. I'm subtracting 3 from it first and getting 0, so 0's y value is getting assigned to 3 now. So whatever this y value was, which would be 0, now it's getting assigned up here. So this gets moved up to there, so all your x's are getting shifted, and that's why it goes left and right then. Okay, so and it's the opposite of what you think when you're subtracting. It's actually going to the right, and if you're adding, you're actually going to the left. Okay, so a family of functions is a group of functions with common characteristics. A parent function, which coincidentally I've seen some textbooks call them mother functions, and you can probably guess why that is not used as often. If you say it a little too fast, it doesn't sound so appropriate. So yeah, it's called a parent function. Most newer textbooks call it, and it's the simplest function with those characteristics. So like this would be the parent function. Sorry, this would be the parent function for the absolute value, just the basic V shape at the origin. There is a typo here. There should be a K. So if K is a positive real number, to graph any function, in fact, plus K, shift the graph. This one's going to be up K units from the parent function. So if it was a plus and K is positive, it's a plus, go up. And down here, if it's a positive, K is positive, but that's a minus, it's going to be down. So if I wanted to graph +1, I'm just going to go up 1, put my dot. Now, the normal absolute value function has a slope of 1 going this way and -1 going this way. That's a -1 slope, +1 slope. If I wanted to go absolute value of x -4, go down 4 units, slope of 1, and slope of -1. Okay, those are supposed to be straight. Now, H, if it's on the outside, we call it K. If it's on the inside, we call it H, just to keep it separate. One's H, one's K. If H is positive, and I have a plus, remember plus is the opposite of what you think, it's going to be left. I'm going to go left H units from the parent function. And to graph this, if it's a minus, where H is a positive number, I'm going to go right. I'm going to go right H units. Okay, it's like this guy right here. If I have a plus 3 here, then that's going to be left 3 units. So 1, 2, 3. That's where your vertex is, the corner of the V shape, and then go this way, and then this way. Okay. Minus 4 would be 4 to the right. So I'm a 1, 2, 3, 4. Slope of 1, slope of -1 going the other direction. Okay, now let's flip this over. Now we've got some combinations here. So I'm going to give you the parent function. I'm going to tell you what the shift is, and then we want to try to figure out what the equation would be. So write the equation. This is just kind of for your help. I don't know if I really need to do it or not, but well, let's say this one right here. Let's make that a plus because we haven't talked about that yet. So let's make that a plus. So if we were going to take this parent function, I want to shift it 2 units down and 3 units left. So that would be the absolute value of x. And if I want, so left and right goes in the inside. Now 3 units to the left would be a plus 3, and then 2 units down would be a minus 2. Okay. And if you want to practice these, pause now, maybe fill these two out, and then you can hit play and see if you did it right. So this would be, I'm going to go up and to the right, so I'm going to go x. If it's to the right, it'd be minus 4. If it's up, it'd be plus 1. And then this guy, x, I'm going right 2, so that's minus 2, and then I'm on 4 down, so that's minus 4. Okay, so if it helps you, you can graph them over here. I'm going to skip that step. For some reason, I thought that would be helpful, but not so much. Now, not so easy to see. I apologize about the prim. These are equal signs, and this is just having or it's more of the same thing. This is basically saying that this applies to all functions, but minus plus inside with the x means right and left. Minus is right, plus is left. Any function could be x squared plus 4. It could be a square root of x plus 4, or it could be an absolute value of x plus 4. It could be anything. So any function, not just absolute value. That's all we're really saying here with this guy. Okay, and then the next part here, I messed up and I didn't type in the functions I wanted you to compare. So I meant to type these in before I hit print so you guys could see these. And what I want to do is I want to try to match them up with these right here, where if it's a function that reflects across the x-axis, you want to put a negative out front, and that'll make it flip over this way, flip that way. Whereas if you have put a negative in with the x, it'll flip this way. Okay, and if about the origin, that means it's gonna flip and then flip again, which is gonna be like being reflexive about the origin. So it's a negative for both. So let's type these in. I'll see if I can scoot these over enough and I can bring my Desmos back into the screen. I want to compare both of these. I'm going to do A to B first. Okay, so I got A typed in here, and then B, all I did, well, actually, not all I did, I changed all of them. I changed all of the values, so positive to negative, positive, negative, negative, positive. So it's a situation where I literally took the opposite of the function. So this would be like a situation here on the first one, where it's a y equals negative f of x. So what should happen is this should flip about the y-axis. So when I turn this on, see it is flipped over. Okay, so these points up here went down there, and these points down here went up there. So it flipped over about. So that situation right there, make some room here. This is the first situation. Okay, that is the exact opposite function. Every term of the polynomial switch signs. Now I'm going to do that, type in that second one. So I'm going to change this so that this is a minus here. And maybe I'll turn this off for a second. So there's my original function, and there's that. So what that is I put a negative in for every x. If I put a negative in here for that x, that term's going to change. If I put a negative for that x, that term's going to change. This one doesn't have an x, so it doesn't change. And that's why this last one is not affected, is because I put a negative in for the x. So I put negative x in for all the x's. That reflects this way. You can see in the graph there, it reflected across the y-axis. Okay, so this would be the second situation. And then the last one here, I'm going to change. So this needs to be positive. This is positive. This is positive. Let's see here. Let's turn this off. And yeah, so this one, if I turn this off, think about it getting flipped over and then flipping this way, that way. I don't know if that makes any sense. And let me put the other two in here. Let me put the intermediate steps. So it's kind of hard to see. Here's my original function. Here's the functions on the left, the first one, and then f is this guy here, the second function. So maybe let's look at just some intermediate steps. So first, if I flip it about the x-axis, I got this. So you can see how that gets flipped about the x-axis. Now let's flip that about the y-axis. And there's my answer. Comparing these two, they look nothing alike, but that's actually the red function flipped out the x-axis, which is this. This is flipped about the x-axis. Then take that green and flip it about the y-axis, you get the blue. Okay, so it got flipped both times about both axes. That's the third option. There is if you plugged in negative x, simplified, then switch all the signs. This is what you get here, the third option. Okay. Hopefully that wasn't too confusing, but just to see what happened with that graph. Maybe that Desmos, hopefully that helped, but maybe it confused him more than anything. But yeah, let me know if you have questions.